first board, right? Where I will be talking about BGP introduction, and this will be simply in case of IPv4, right? So there is not much difference when we talk about BGP for IPv6 or BGP for IPv4. There is one concept which is an interesting concept that is I'm going to talk about, but overall the working will be same. So what I have here, I have two routers here, router number 1 and router number 2, right? And I'm running a network between them, which is 192.168.12.0. Here I have say 12.1/24. Here I have 12.2/24, and that is it. If I talk about BGP, you all understand that BGP is definitely different than IGPs, and IGP's protocols are OSPF, you know this, RIP, and EIGRP. These are the three protocols we have in interior gateway protocol, and the meaning is that if we have one big group, right, inside that group there are multiple routers, then switches, and so many things are there, but this is under the control of one administrative identity, right? Maybe a company, maybe a network administrator or something, right? Then we call this that this is a part of one autonomous system, right? Similarly, we can have another autonomous system. Maybe this is my autonomous system number 1, the other is autonomous system number 2, and then we have multiple routers and switches there, but this is controlled by some other entity, right? And of course, inside these autonomous systems, we can run multiple protocols, maybe whatever this network admin guys like, maybe we can run here OSPF. This guy like EIGRP, we can run EIGRP here, right? But what is going to happen when we talk about between autonomous systems? So there is a protocol, which is a single protocol, which is known as exterior gateway protocol, the BGP, right? We run this protocol between autonomous system numbers. And the scale of BGP is huge. Why? What is the meaning? The meaning is it can handle lakhs and lakhs of routes. But this is not the scale of IGP, believe me. OSPF, RIP, and EIGRP cannot handle the routes or the scale of routes which BGP can handle. This is only one reason of using BGP as EGP, right, or exterior gateway protocol, or between autonomous system number. There are multiple reasons, right? So if you want to really understand BGP, I have created a phenomenal course on this, 20 hours long, approximately 22 hours long, but it will give you a clear picture of BGP. Today, the intent is not to teach BGP to you. The intent is how we are going to advertise our IPv6 route in BGP. Do we need a new protocol? For example, in case of OSPF, we need OSPF version 3, right? To understand that, let's talk about a little bit about BGP. So if you want to run a BGP between these two routers, R1 and R2, and suppose I have one loopback interface here, which I have configured, and the IP address which I have configured there is 11.11.11.0/24. What I want to do is I want to run BGP between R1 and R2, right? And then I want to advertise this network so that R2 can learn that I have learned a route, which is BGP route, which is 11.11.11.0/24. This is the whole sole agenda. So the configuration piece is really, really simple. As I mentioned, BGP is a protocol between autonomous systems. So we have two different autonomous systems here. We have AS100, and R1 belongs to autonomous system number 100. And we have another one, which is 200. And we are running BGP between two different autonomous system numbers, right? If that is the case, the configuration is simple. At R1, I need to write router BGP 100. We need to define router ID. It should not be routable. It can be, but we do not need it routable because it is just identifying router number 1. As simple as that. Then wherever we want to make the neighborship, right? We have to define that neighbor, and that neighbor is 192.168.12.2. Remote AS is 200. Why? Because R1 wants to make a neighborship with R2, and I advertise or receive routes from my neighbors. This was happening in EIGRP. This was happening in OSPF. So neighborship is must. And here I am uniquely defining my neighborship. I want to neighbor with R2, and R2's IP address is this one, right? This is different as compared to OSPF. In OSPF, we were not defining that I want to peer with this guy. I am just sending my hellos to a multicast address, and whoever is listening on that multicast address, that means that guy is also running OSPF, right? And then we can make an OSPF neighborship. Here, I'm exclusively defined that I want to peer with R2 whose IP address is this one, and which is a part of this autonomous system number, which is 200. If I want to advertise, this loopback interface, then I need to use my network command, and I need to define this subnet and then the mask, as simple as that. And this mask is not in wildcard format. This is the normal mask. As soon as you do this, R2 and R1 will be peering with each other. They will be BGP pairing going on between them, and then we will be learning a route in R2's routing table, which is 11.11.11.0/this, right? If I have another loopback interface here, which is 22.22.22.0, it will be showing as a BGP route here, and these loopback can start pinging each other without any doubt. This is how BGP normally works, and we call this neighborship as external BGP or eBGP. Why? Because this is the neighborship between two different autonomous system numbers. It might be the case that at AS200 we have another router and you want to make a neighborship between them, then it's going to be internal BGP. I think you are all aware of that. One interesting thing which BGP does, which OSPF or EIGRP don't, is that it uses transmission control protocol to first make an initial connection. For example, if I enable BGP on R1 and R2, R1 will be checking that whether there is an R2 or not, which is listening at a particular port. The port number is 179, right? And if it is, then basically the BGP is running there. R2 will be also making the connection there, right? So there is only one TCP connection, doesn't matter who started, but at the end of the connection, R1 knows R2 is there and is listening at 179. R2 knows R1 is there and it is running BGP. As simple as that. So first thing first, BGP starts TCP three-way handshake, and then it will be sending its hello messages, which are here known as open message. Don't worry about it. I will be showcasing those messages to you. Once done, once open messages are exchanged, they will start forming neighborship, because whatever the information they need, right? That information will be in this open message. As simple as that, right? Now let's see what I need to do to send my IPv6 messages or IPv6 routes. So sorry for this, IPv6 routes. And that is where I am coming across a concept which is known as interesting concept. I'm not taking the name because people has little fear about that name, right? Try to understand BGP is exactly same. We are not developing any new protocol, nothing, right? We will be using our BGP protocol, which were taking my IPv4 route previously, right? The same protocol will be taking my IPv6 route. Believe me, IPv6 was designed in such a way that it can take routes of different protocols, right? For example, if I talk about a PE router, provider edge, if you know a little bit about MPLS, just try to think this. In case of MPLS, one provider edge router can have multiple customers. Customer number A, or means customer A, then we have customer B, then we have customer C, and such customers can be in thousands of numbers. And how we identify them? We identify them with route distinguisher and route targets. Route distinguisher, route target. These values are different. Route distinguisher is to differentiate the route. Why do we need to differentiate the route? Because it might be the case that in IPv4 case, this customer A is using a network which is 10.10.10.0/24, and customer C also will be having this route 10.10.10.0, because these are private address ranges. Anybody can use it, and that is where this RD value is really useful. And that is where, because in one router we cannot have two similar looking routes, right? One from customer A, customer C, and that is why we use the concept of VRF. And then you must be thinking, Mr. Vishnu, wait a minute, what are you doing? Where are you going? We are talking about IPv6. Don't worry, I am coming at that point. We need to understand few concepts of IPv4 to understand this interesting concept. So now, suppose I want to send this to, suppose this is Delhi, and another P2 router is basically in Bangalore. I would like to send customer A routes to customer A routes in Bangalore location because customer A is here also. I need to make sure that these routes reaches here. So what I can do, I can make maybe 3 different BGP peering between them, right? In case of 1,000 customers, there is going to be 1,000 BGP pairings, right? Not an scalable solution. Or I can make one neighborship and I have to send all these routes. But how I can do this? Because this route and this route is same. And that is why this BGP neighborship is capable of sending somewhat different looking route. For example, when the route comes from here, from customer A, it will be saying that 10.10.10.0/24 is from customer A, and it will be attaching its RD value. Maybe say it is 1:100. 1:100 is specifying customer A. But now see the route has changed. Route, right? It is absolutely different. Because if I have another route which is saying 10:10:10:0/24, which is maybe say 2:200 or 3:300, this is specifying customer number C. But normal BGP cannot take this route with this RD value because normal BGP can take only IP addresses. And that is why BGP has extra capability. It can take this route also, believe me guys. But these routes come into the category which is known as VPN v4 routes. There are multicast routes also. And nowadays, one protocol which is everywhere in every data center, that is VXLAN with BGP EVPN, where we are not sending IP routes, IPv6 route. We are literally sending the MAC addresses, and our BGP can literally take it. This MAC is known as basically BGP EVPN address, right? Interesting. Try to understand one protocol taking multiple or different kind of routes, different kind of family of routes, right? If you still don't get it, I think you got it. But, and by the way, these are known as different families of addresses. This is my IPv4 address family. This is my IPv6 address family, VPN v4 address family, multicast address family, EVPN address family, all are part of BGP. But if we spend a lot of time also in BGP and we haven't seen them, that is perfectly fine because the default behavior is IPv4. We, without doing anything, we can send our IP4 routes from router number 1 to router number 2, which we discussed in the previous board. It is as good as saying that if you have gone to airport, which I believe you all have gone to an airport someday in your life, right? Already. What happened? If I talk about Delhi International Airport, India's, right? In this airport, we have different airlines. We have Indigo, we have Air India. There is a recent plane crash. Unfortunate, really unfortunate. Then we have maybe some airlines which are from outside India, British Airways. Then we have Lufthansa and so on. But do we create a separate airport for separate airline? No, right? Although these airlines can be having different processes. Indigo's processes are different than Airways or maybe the Lufthansa or maybe some other thing, right? They can operate differently. How airport is doing all these things? They will say that my gate number 5 to 10 are for Indigo. My gate number 10 to 15 are for Air India. Maybe 15 to 20 are for British Airways. And this is how everything works fine. They have their dedicated space, but airport is going to be same. Just try to understand airport. If you compare or if you think this is an analogy, which is then airport is just like BGP, which can work with IPv4 route. They have a separate gate for IPv4. They have a separate gate for IPv6, for VPN v4 routes, for EVPN routes. Everybody is having the different gates. And by the way, these different gates is nothing but your address family. This is the concept of address families in BGP, right? So let's see the next board where we will see what exactly happens when you configure BGP on R1. and how R1 is going to take it. So suppose we are here and we have run these commands, router BGP 100, because this is part of 100 autonomous system number, BGP router ID, and then I run the neighbor command 192.168.12.2, which is this guy, remote AS 200. Believe me, once you do this, what exactly happened behind the scene, what router one is getting, what router one is understanding, right? Router one says that, of course, I am running a BGP for autonomous system number 100. My router ID is this one, right? Leave this command, and my neighbor is this one. But it also understands that because I have various gates, I have various protocols, which protocol routes I'm going to advertise, right? It is having address family of VP and V4, it is having address family of IPv6, and so on. Most widely used is IPv4. So by default, it thinks that it is perfect to start with IPv4 because we presume that everybody wants to configure IPv4, right? And that is why it says that this neighbor is part of address family IPv4. It happens by default. Believe me, you just try to write address family IPv4 and you will see this command popping up. Sorry, not this one, neighbor. And if you have given this network command, this will also be here. So here you can see neighbor 192.168.12.2 activate. The meaning is this neighbor is activated in IPv4 address family, and I'm advertising 11.11.11.0 subnet in my IPv4 address family. Maybe this 11.11.11 is any loopback here, which I have configured. Really interesting, right? But why default? What is the meaning of default? The meaning of default, let's understand this with also an example. Suppose you have purchased a mobile phone of Samsung or maybe Apple or whatever, right? When you get this mobile phone, you see a wallpaper, right? When you switch it on. Was it selected by you? No, it came by default. It came with a ringtone. Did you select it? No, it came by default because we expect that these things should be there. So the provider or whoever is the manufacturer, they decide, right? And sometimes some problems also happens. For example, if 10 people have 10 mobile phones and they haven't changed the default, right? And if somebody's phone rings, then everybody think that this is their phone because they haven't changed the default ringtone, right? I think you must have noticed this. So the concept of default is simple. You have to choose something to begin with, and that is your default. In BGP also, you need something to begin with, and the address family IPv4 is default. So you just configure this command and configure one more command, address family IPv4, and believe me, these commands will be automatically popping up there. It means that what you need to do, if you want to advertise your IPv6 route, you need to write here address family IPv6 and neighbor activate. If you want to advertise your multicast, address family multicast. If you want to advertise VPN v4 route, the alien looking route, then you have to address family, right? VPN v4, and then you have to advertise or activate the neighbor there. As simple as that, right? So now let's talk about the IPv6 configuration, which you can easily do, right? And we are right here, and we have BGP for IPv6. Very simple configuration. Again, we have router number 1, we have router number 2. Now we have subnet here, right? 2001 colon 12 colon 1 and 12 colon 2. So sorry for this, right? This is the configuration at R1. Very simple configuration, right? Now the neighbor is IPv6 address, remote AS is 200. I am presuming this is my 200 autonomous system number. And now I have run in specific command. I do not want IPv4 to be run here, right? So what I'm doing here, I am saying no BGP default IPv4 unicast. I do not want because there is no IPv4 here. I'm running in this network. I do not want the default. It should run, right? And this is going to be the case in upcoming 5 to 10 years, guys. We were talking about that there was a protocol IPv4 ARP was there in that, right? It will be like this because there is no IPv4 addresses now, right? So then if you see address family IPv4, there is nothing inside it because we do not have any IPv4 address, and we are saying that no BGP default IPv4. And now we have defined address family IPv6. Inside address family IPv6, I have defined the neighbor 12:2, which is my router number 2. I am activating it and I am advertising this network, which is nothing but a loopback, address configured on my R1 interface, which is 2001 colon 1111 colon 1111 colon 64. This is the loopback address I have configured here, and I want to advertise this in BGP. That is why I am using this network command and specifying this network. When I do this, R2 will be having the same thing here. That means the route will be popping up here. Similarly, you can understand the concept of configuration, or basically this configuration at R2. Guys, do you have any doubt till now, or are we good? Anybody? Any doubt? Any question? I think we are good. Okay.